delivering its own functionality, and it gives the functionality on the sender side. Suppose we are discussing about transport layer, so it takes some data from or a message from the application layer and then sends it to the lower layer, network layer, and it has its own functionality. We'll discuss what is the functionality of each layer now. So the transport layer is basically now we are starting discussing its from physical layer, starting from the physical layer. So what is the responsibility or what is the function of physical layer? The basic function of physical layer is to transfer the bits from the source through the destination. We have seen this diagram. So the identical objects at physical layer are bits. So this physical layer will transfer the bits through its routers and switches, and it will be delivered to the physical layer on the other side. Now, what do you mean by bits? Bits is the representation of the data that is either 0 or 1. But can we send 0 and 1 through the wire? Anyone? Can we send?
No, ma'am.
Yes.
No, ma'am.
And so you must have heard about the coaxial cable, twisted pair, and optical fibers. So no transmission media, even Wi-Fi, wireless medium also, you cannot send bits, zeros and ones you cannot send. This is just a representation or a symbolic meaning for a particular signal. So if you're sending an optical signal, suppose light on and off. So if you say if the light is on in a particular moment of time, it is treated as 1, and if it is light is absent, it is treated as 0. So that is the interpretation of the signal which is being transmitted. That can be an optical signal, that can be an electrical signal, analog signal, or a digital signal, anything, DC or AC, whatever. So basically your the objects which are transferred at the physical layer are bits. So physical layer, it is although the physical layer, now we see that in TCP/IP model we have seen that the physical layer is the lowest layer, but physical layer is just a logical connection. There is actual physical media which is operating below the physical layer. So we can also add a actual layer below that. This is the logical connection. Physical layer on host A, that is the sender side, and the receiver side. Both the sides is a logical connection. So we are saying that we are logically transferring the bits from one physical layer to the other side. So actual physical transmission media, physical media is basically the transmission of signals, which is transferring the signals, and that is being interpreted by the sender side and the receiver side as bits, zeros and ones. So that is the physical layer protocol, to interpret the signals at both the sides and to deliver the bits from one side to another. Then data link layer. Now what is the purpose of data link layer? It is to create a link between the LANs and the WANs. So the basic purpose of data link layer is that if we have a switch or a router, so we have to actually find out the actual physical link or the path from one end of the connection to another end. Suppose there are 5 systems connected on a ring or a bus. So when I am transferring the data on a ring, I have to transfer the data from machine 1 to machine 2, which is the next machine on the ring, then machine 2 to machine 3, machine 3 to machine 4. And then this is only the transfer of data exactly from one place to another. This is the basically function of data link layer. Now assume that you are playing a game. I'm giving you a real life analogy for this token ring and ring topology. Suppose you are playing passing the parcel and you are all sitting in a circle. So what is basically the function of each of you who are participating in the game? So each person who is participating in the game and passing the parcel, they are responsible for transferring that parcel from one person to another, the nearest one, the neighbor one. So this is the basically function of data link layer. So it is not responsible for transferring the data from end to end. End-to-end transmission is not, end-to-end means host to host, source to destination is not required, but end-to-end, it is basically, normally it is said as end-to-end because this is one end of the link to another end of the link, only between a wire. Suppose I am sending my parcel, passing the parcel game, if I am saying one friend is sitting on next to another one, then the data link layer is treating that passing the parcel as being transferred from one friend to another friend, the nearest one only, the next one only, not to the destination. So in when we are talking of data link layer, we say it takes the bits at the receiving side, it takes the bits from the physical layer and make sure that all the bits which have been transferred as a packet, as a frame to the data link layer, it has been transferred properly. So it may happen that signals may be interpreted wrongly. Now, suppose data link layer on the sender side, it has sent a packet or a frame basically to the physical layer, and now frame this physical layer is only responsible for transferring the bits to the other side. Now, suppose in passing the parcel game, if you assume passing the parcel game, and if you say the parcel is divided into various small packets, so you are responsible for transferring the whole packet in chunks to the other person, to the nearest friend. So if suppose there are 4 sub packets in passing the parcel, so it is, you have to ensure that you have passed all the 4 sub packets to the nearest friend. That is the responsibility of the data link layer. I hope I am clear to all of you. Is it clear? Data link layer is from one end of the connection to the other end, and whatever bits the physical layer is being transmitting, those all bits are being transferred from one end of the connection to other in the same sequence and without any error, without any problem. So all the bits should be transferred in the same sequence. So if suppose I have numbered the sub packets in the packet as one sub packet, second sub packet, third sub packet, and fourth sub packet. So all the packets should be received by the data link layer, and all the packets should be received by the friend which is next to you in the game, and all the 4 packets should be delivered correctly to the other end. No sub packet should be dropped. This is the responsibility of the data link layer. So when the next link to travel is determined by the router, the data link layer is responsible for taking the datagram and moving it across the link. The link can be a wired LAN with a link layer switch, a wireless LAN, or a wired WAN, or a wireless LAN. You can also have different protocols used in link, right? So in each case, the link layer is responsible for moving the packet through that link. Only the responsibility of data link layer is from one end of the link, the other end it has to send the packet correctly. No problem, no error. For data link use and the data further. Some facilities or the services which are it can provide complete error detection and correction. Some provide only error correction. So suppose as for the bits, as suppose you are transferring the data as, what is the binary code for F? What is the binary code for F?
Small f or capital F?
No, this is not alphabet F. This is suppose hexadecimal F. If I say
4 times 1.
And 4 times 1.
What is equivalent to binary equivalent of hexadecimal F?
4 times 1.
4 times 1. Or what is the equivalent of alphabet A in ASCII?
65.
65. But if you convert it to this binary, what will be the equivalent of 65? What is the binary equivalent of 65?
1, then 5 times zeros and 1.
Yeah, 64 is 1 and preceding 6 zeros, and then last 0 is 1. Okay?
1, then 5 times 0, and then last 0
Yeah,
is 1.
yeah.
Like last is.
Yeah. So this is 65. So suppose you have sent 65 as bits, but there is some fluctuation in the wire or in the signals, and suppose that bit is represented suppose you are representing those as signals, voltage signals. So suppose that instead of 10 volts there was some spike, electrical spike, and that 10 volts was uh, basically was misinterpreted as 5 volts. So that 1 was interpreted as 0. So instead of sending 65, you have sent 64, or it has been interpreted as 64 at the other end. So instead of 1, the last bit has been represented as 0. Or maybe the first bit you have sent, that the 64, the weightage, the bit which carries the weightage 64, it has been misinterpreted as 0. Then what would happen? Instead of 65, it will be treated as 1. So the entire data you were sending is misinterpreted. So this whole thing will be taken care of by the data link layer from one end of the link to the other end. So if some bits have been inverted due to some electrical voltage spikes or voltage fluctuations, then it will take care of, and it has some algorithms to do error control, error detection and error correction also. We'll discuss it in the MAC layer protocols when we'll discuss data link layer and MAC layer protocols. So this is the basic functionality of data link layer, to do error control and error correction and error detection, and to do framing of the bits, to create make a frame of bits. So physical layer will only treat 1 as 1, 0 as 0. That's it. This is the function of physical layer. But data link layer will take care that all these ones and zeros belong to one frame, and that frame is basically an alphabet which contains the value 65. So this is basically the function of data link layer, to encapsulate the whole datagram, the entire information as one frame or one packet. Then network layer. Network layer is responsible for creating a connection between source computer and destination computer. Now, when we are talking of suppose mobile technology, when you are connected to, or maybe you are connecting your laptop. So when you are connected to the internet and you are sending information from your laptop to your friend's laptop, then the network layer comes into existence, and it will find a route from your laptop. It will find a route to the nearest network, to which you are connected. Suppose you are connected to your Wi-Fi or your LAN, wired LAN you are connected to, and then from that LAN it will find a router, and then the intermediate routers, so many intermediate routers, and then your friend's network it will reach, and it will find a path. So network layer is responsible for finding a connection, for creating a connection between the source laptop or the source computer to the destination computer. And the communication at the network layer is from host to host. So as you can see in this pic, this is my source computer, source device, and this is my destination device on the right hand side, and in between you have the router. So this is the simplest model we are seeing, but it's not always possible that your source and the destination machines are only connected through only a single router. It may have a number of routers in between. Suppose your friend is sitting in US and you are sitting in India, so there will be n number of routers through which you are connected. So you'll be connected to your, suppose, Airtel hotspot, your Airtel Wi-Fi. Then Airtel Wi-Fi will be connected to its own hub in Airtel office, the nearest Airtel office. The nearest Airtel office will be connected to the main ISP or NIC of Delhi, Network Information Center, NIC, the Government of India, and then it will be connected to some other router in US, and so on. So it's not necessary that your network only contains only a single router or two routers. It always depends on which network the two machines, the source machine and the destination machines, are connected, and it may use n number of routers and switches in between. So network layer is basically responsible for transferring the data packets from the source machine to the destination machine. This is host to host. So that's the purpose of network layer. But we have seen that data link layer is responsible for transferring the data from one end of the link to another end, one machine to another machine. It may be one switch to another switch. It may be one router to another router. That's it. Or one host machine to another machine, which is nearest to it. So it's not responsible for host to host transmission or source to destination transmission. Then it is for routing the packets. So again, why we need a network layer? If we are saying that it is a host to host network layer communication is basically host to host, then what is the usage of network layer if we already have a transport layer which are also operating, transport layer protocol which is also operating from host to host or source to destination? Why do we need a network layer protocol? because we may have different type of transport layer protocols, as we'll see that we may have different applications and we may use different types of transport layer protocols. Because you can see, I'll just give you a brief idea what are the different types of protocols. The main protocol is transmission control protocol, which is basically connection oriented protocol, and it first establishes a logical connection between transport layers at two hosts before transferring the data. Now this logical connection is also responsible for flow control, error control, and flow control and error control. So basically, what do you mean by flow control? Matching the sending data rate of the source host with the receiving data rate of a destination host to prevent overwhelming of the destination. Now suppose the real life example. I'm delivering the lecture now, and if I say if my speed is super fast and you are not able to grasp whatever I am teaching you, then that is of no worth. So that is not useful. So whenever you will feel overwhelmed by the amount of information or the speed with which you are processing the information I am delivering, then you can stop me and you can say, ma'am, please stop and be a little bit slow, so that we can grasp the information you are being transmitting or you're delivering. So that is known as flow control. So I'm the sender and you are the recipient, and if the flow at which I am delivering, I am sending the packets, I am sending the information, and if you're not able to process that information at the same speed, then it will be overflow of the information, and that is you are being overwhelmed by the amount of data which is to be processed in a specific amount of time. So that is being done by transmission control protocol, because it is controlling the transmission of the data from the host machine, sender host machine, to the destination host machine. So that is the function of transport layer in case if we are using TCP protocol at the transport layer. Moreover, it is also responsible for error control to guarantee that the segments arrive at the destination without error and resending the corrupted ones. Now, suppose in the same example, if I'm connected to all of you and if I'm sending some data to you which is not delivered properly, or suppose I'm showing my slides to you and the same slide is not shown on your screen which I am talking about, then I can resend the data, I can restart my machine, and I can resend the restart and share my screen at which the error started occurring. So this is error control. So TCP is basically responsible for making a connection to the destination, from source to destination, fully committed or a full-fledged connection. And that point of time, suppose I am using, so this is an example of TCP. So I am making a connection oriented protocol. I am we are actually communicating over a connection oriented protocol, because I am not simultaneously doing anything. I'm just delivering my lecture to you and I'm connected to your class only. So this is a connection oriented protocol, and whatever I'm delivering, if it is not being processed at the same speed by all of you, you can always ask me as a sender that please do flow control and be a bit slow, so that we can process the information at the same speed. This is flow control. And error control is if somehow I have delivered, if my network or you have some network issues and I am not doing some, I'm not sharing the same screen as what I am discussing about, and if that is being done somehow, if it is in error, I can always restart and I can always show you the correct slides about which I am discussing. So that is error control. So this is a kind of transmission control protocol. And another type of transport layer protocol is UDP. That is user datagram protocol, which is a connectionless protocol that transmits user datagrams without first creating a logical connection. Now suppose if I say I have sent a mail or a WhatsApp message to the whole class individually, or maybe I have done some assessment, I have given some assignment on Google Classroom or maybe Microsoft Teams or any other platform. So if I say I am not connected to you directly, I am not in a connected mode in the present moment, and I am sending only the messages through some other medium, it may happen that my data will not be delivered to you on time, on the same time, in the live mode or in the same moment of time, and some of the packets or some of the messages may be lost due to the connection errors or internet errors. So that is, or it may be having some congestions on the internet, therefore my messages may not be delivered. Now suppose I say I have sent the messages for some of my lectures, or I have sent some of my lectures to all of you on WhatsApp, or individual messages to all of you. It may happen that your telephone number or your internet is not working at that moment of time, and you may have missed those messages which have already been processed by other students in the class. So some of you may have missed the messages because of your error in your internet connection, or the slow internet connection. You may not receive all my messages, all my information which I have sent to every user. So that is, I am not making a individual connection to all of you through Google Meet or some other media, and I am sending the individual packets. Now it may happen that a bigger file may not be processed by your internet connection, or sometimes you must have seen that when you forward something or when you send something on WhatsApp, what happens, the text message which was supposed to be sent after the video or the pic, it is sent first and the video will be sent later. Have you seen that?
Yes, ma'am.
Yes, ma'am.
Yes, that's because the size of your text message is small, and your size of your this video or audio file or any other type of file is bigger, and it is transferred. So that's the reason your data may arrive out of order, and it may you may be confused with the meaning of the is with user datagram protocol, because that is connectionless protocol. And normally what happens that it say when we are connected to the other person, it is a pipe like what do you say, pipe. First packet we receive the receiver first, then the second. The same order will be retained by receiver side. But in user data protocol, because this is connectionless, there is no pipe connection, all the packets may be may travel through the there is no flow control, there is no control user data protocol, and there is no connection.
Ma'am, this is breaking.
Now, is it okay now?
Yes, ma'am.
User data. Now I'll give you another real life analogy of user datagram protocol. Now suppose I am. We all have to travel to college from different destinations. Okay, so if I say I have. So
Ma'am, you are not audible.
I'm not audible.
Now you are. Yes, ma'am.
To come to the college through only one gate, and at the gate you have to mark your attendance. Roll numbers have arrived from roll number 1 to suppose 9 or up to 5 or up to 20. Then
Ma'am, your voice
so that is
breaking.
Is it again big breaking?
It's breaking. You are not audible. Ma'am, it is breaking.
Yes, ma'am.
I'm sitting in the same posture and I'm using wrong with the internet connection here. Is it fine now? Students?
Yes, ma'am.
Yes, ma'am.
When there is some error, okay? So now you can see the live example.
Yes, ma'am. Your
Ma'am,
voice
it's
is fluctuating.
Hello?
मैम अभी भी आपकी वॉइस ब्रेक हो रही है.
Oh. And we are simulating transmission control protocol, TCP, isn't it?
Yes, ma'am.
Yeah, I'm using another headphone. Just wait. Yes, now is it okay for all of you?
Yes, ma'am.
Yes, ma'am.
Now I have connected from my phone directly. So, wait. So, as we have just saw to our real life example, the transmission control protocol. So you were not receiving the packets and you were using some of the packets and there was some disruption in the audio which was being delivered from my host machine to your recipient machine. So we were using we were just simulating the TCP protocol in this particular moment. So we did error control and we did flow control also. So whatever we have guaranteed that the segments arrive at the destination without error and resending the corrupted ones. So I'm resending the corrupted packets and I'm just delivering my lecture again through another machine and I'm trying to resend the data. This is transmission control protocol. Okay. Then next is user datagram protocol, which we were discussing. So now suppose I ask you to come from different routes, bus routes or different metro routes, and you all of you have started from your homes at the same time to for joining the college. Suppose there is a function, annual day on Sunday in the college, maybe around 10 o'clock, and you all have started. And if I ask you to start at 8, all of you to start at 8 o'clock, then you may arrive out of order and you may use different paths to come to the college. And now a person who may have started at 8 o'clock may reach the college at 10, exactly 10 or 10:15. But a student who may have started at 9 o'clock, it may reach the college from the same destination, maybe same place. She may arrive early or she may arrive on time. So that's the UDP protocol, connectionless. So there is no connection, there is no set path. You may follow a less congested path. Suppose some person has taken metro and metro is less congested, so it will come properly. But some other friend of yours, she has taken a route which was more congested. It had traffic, and she had taken a cab also, but she could not arrive on time because of the congestion on the traffic on the path. Some other girl also, some of your friend must have taken a bus from the same location. She may arrive on time also, but the person who has taken a cab, the shortest path she may have followed, but it was because it was having traffic and it was congested, she may arrive late. So that is the flow control, the congestion control in UDP. So there is no congestion control in UDP. The packets which have started early may arrive out late, and the packets which have started late, they may arrive at the destination early. and the packets may be in error also. So if I have sent you some messages, so due to some other spam software or some other thing, the packet may arrive in error. So you will not be able to understand what I have sent. So that is error. And there is no flow control. As I told you, if you have sent a larger file, it may arrive late. It may be received at the destination late, but a small text message will be received early. So that is all under UDP. Then we also we'll be discussing later SCTP, that is Stream Control Transmission Protocol. As the name suggests, stream control is basically for multimedia applications. Nowadays, we are using YouTube and all other streaming applications. So multimedia streaming uses SCTP protocol for transmission of multimedia. Then application layer protocol. So if you already have application this transport layer, why do we need application layer protocol? So basically, communication is also done when the communication is done through all the layers, physical layer, and you are logically connected through all the layers, physical layer, data link layer, network layer, transport layer. We can have process to process communication is the duty of the application. Now suppose you may have 3 applications running simultaneously on your mobile phone or a laptop. You may be having your Yahoo Mail, you may be opening your Instagram also, and you may have your web WhatsApp opened on your laptop. So there are 3 different processes, there are 3 different applications which are running on your laptop. That is the application layer. Okay, but each application